It would take about 200 of these file boxes, or about 1,500 floppy disks, to store what you can get on one compact disc. Is it any wonder that optical storage is the talk of the computer industry? Today, we take a look at the CD-ROM on this edition of the Computer Chronicles.
The Computer Chronicles is made possible in part by AFIPS, the American Federation of Information Processing Societies. AFIPS, along with these constituent societies, brings you the National Computer Conference, NCC 86, offering a showcase of advanced technology and the industry's foremost professional program. For conference information, call 800-NCC-1986. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.
Welcome to the Computer Chronicles. I'm Stewart Cheifet, and this is Gary Kildall. Gary, you know, about a year ago, there was not a single laser beam in my house. I was laser-free, but during the past year, I had to go out and buy a laser video disc machine, and then, of course, a laser audio player, a compact disc machine, and now I'm getting into a CD-ROM disk drive for my computer. It seems that optical storage is just taking off now. Now, is optical storage just another small step in storage technology, or is this a giant leap for computers?
Well, I think my biases may show up in this particular case. I'm very interested in optical storage. From a hardware evolution standpoint, we've been working with magnetic storage ever since the 40s. Now, optical storage gets us orders of magnitude more information in the same amount of space. Now, with that tons and tons of information we're able to store, if we organize and index it properly, that means we can replace whole libraries and maybe even someday replace the printed page.
On today's program, we're going to take a look at laser storage, optical storage technology. We're going to look at an encyclopedia on a laser disc, something you may know a little bit about. We're going to see a worm disk, a laser disc you can write to, and we'll see massive databases that you can buy, not online, but on a laser disc. We're going to begin by taking a look at the technology of optical storage.
The magnetic disc, preeminent recording medium for most computers, could soon become a fringe accessory as the vastly more powerful optical disc comes closer to being mass-produced. Offering up to 1,000 times more storage than magnetic media in the same format, the read-only optical disc records information in small pits or bubbles burned in by a high-intensity laser. These encoded marks, much smaller than those on magnetic discs, are later read back by a low-energy laser beam. The long-awaited erasable disc is actually a magneto-optical medium, using a laser to change the polarity of magnetized spots in the light-sensitive surface. Still in its infancy, this industry is faced with several different standards, from 120mm read-only CD-ROMs to several kinds of 130mm or 5¼ writable discs.
The compact disc standard, or CD-ROM, is ideal for pre-recorded databases where you would logically go in sequential fashion. For example, if you're searching a large database, this is an ideal methodology. It is, however, too slow for direct access of computer information, particularly computer software. We feel there is a need for a rapid access version where the disk would rotate at constant RPM, constant angular velocity, and the optical head will zip back and forth by reading the format information. And the key is that it'll be physically interchangeable in the same disk drive as this in its write-once form and with the erasable read-write disk.
The enormous capacity of CD-ROMs, about 250 megabytes per side, has attracted much attention from manufacturers at a time when computer sales are leveling off.
Why is the computer industry in a slump today? Because there are, in an average building like this building right here, I probably have 30 personal computers in this relatively small building, of which at any one time 25 are gathering dust. There has not been enough easy, accessible user applicability developed to make it a tool that the average person finds easy and comfortable and worthwhile. What optical provides is one more part of the jigsaw puzzle. Only one part, not the total part, but at least an important part of solving the jigsaw puzzle of making that immense power that's available in the personal computer usable to the average person.
As with the first PCs, finding clever uses for the voracious optical disc is just a matter of time. But for a technology that shows such promise from the start, the future is even more remarkable.
But there is a very clear route in optical to put such increase of density on the disc that it becomes almost no longer a question of any limit possible. It becomes to the point where a single disc can approach the human brain.
Joining us now in the studio is Tim Oren. Tim is a designer with ActiVenture, a company involved in CD-ROM software development. And next to Tim, Dr. Robert Kaltoff, CEO of Access Corporation of Cincinnati, a company involved in optical storage technologies. And Gary, I suppose I should kind of introduce you on this particular program and make clear that you have a rather special interest in optical storage. You're the founder of ActiVenture and Tim's boss. Gary, let me ask you the first question then. It's a long way from CPM to CD-ROM. What is it about optical storage that got you so fascinated in it?
Well, about 2 years ago, Digital Research was doing a project in video discs that I was directing, and the project was dropped, and I asked permission from the board of directors if I could go out and form a company to pursue optical publishing. And it's just that tremendous amount of information that you can store out there. What do you do with it? An encyclopedia is sort of a prototypical example, so I thought I'd chase that one down.
Okay, we'll get to your encyclopedia in just a minute. Bob, in general, is optical storage something that we're seeing as something that will replace magnetic storage devices or that will work with magnetic storage devices?
Certainly with. I doubt that it will replace it at all.
Why?
Because I think that you're talking about in computer applications.
Yes, yes.
I think optical disc is probably 5 years away from the time that that could be even possible. In the meantime, you're going to have erasable optical disc media that will be in there, and that would probably have an effect long before the fixed disc itself could.
Okay, Gary, let's get back to your encyclopedia reference. Now, we have, in fact, the full set of books in the encyclopedia behind Tim there, Grolier's Academic American Encyclopedia, which you claim you can squeeze onto that 4 3/4-inch disc. Did you do it?
Well, it's text only, and that's the same as the online system, basically. And it's actually stored in a ring that's only about 3/8 of an inch wide on the disc. It's about 20% of the disc is full. And so the remainder, if you have pictures of your grandchildren you want to put on there, whatever.
So you get it on a small portion of one side of that disc.
And in fact, half of that is the encyclopedia, and the other half is indexing information telling us where things are located.
Now, Tim, you're involved in the user interface aspect of the product. And let me ask you, my first reaction is, I mean, I'm comfortable with all those books, and if I want to go to the encyclopedia and look for volume A, I pick it up, pull it out, I thumb through the pages, and it's very easy. It seems to me rather difficult to have to use a mouse and a keyboard to do the same thing. How did you solve that problem?
Well, I'm glad you put it that way, because if you look at the screen, we did exactly what you suggested, which is we put the 26 letters of the alphabet up there in a bookshelf representing the books.
So they're my volumes.
Right, and just take the mouse and point to the one you want. And let's go look something up. Let's, for instance, go look for the Polar Explorer, Raoul Amundsen, who's in the volume A. So we point at it and click, and it's going out.
You essentially pulled out volume A, and there it is.
There it is. There is on the screen, and we look in the alphabetical order, and this is the one we need to select, and it's working its way down through the volume here, giving us finer and finer divisions. Then finally we go down and find the article titles, and here they are just as if we were thumbing through that section of the encyclopedia, and we can point to the title we wish to examine.
So you're just pulling out that article now.
That's right, and here it is, the exploits of Raoul Amundsen.
From this point you can page back and forth, take a look at the article and things of that sort. Now that's all in the CD-ROM that's in this player right here.
And what's the amount of storage involved? How much, what's the
this is
capacity?
550 megabytes. 500 million bytes of information, enough to stretch 10 characters per inch from here to Denver.
And in fact, you're not using the 550.
That's right.
Okay, now, Tim, that's an easy case. Suppose, I take it one of the advantages of this system is you can do a kind of word search. Suppose, for example, I want to know about PBS, but there's no listing for PBS in the encyclopedia. Right. How would I use this?
Okay, we go out and go over to the word search, and it's asking us here for PBS. Okay, so we have that typed in. Okay. And we go over and hit search.
Okay, so now it's searching the entire 20 volumes to find any reference to PBS.
Found 33 occurrences of PBS and 16 articles, and now we're going to ask.
And it did in about a second.
Yeah. And now it's going out now, and it's going to give us all the titles, the articles.
Now, this request can be much more complicated, of course. It can say, I want this and this or this, you know, combinations of things of that sort.
Okay.
What they call Boolean searches, but we're trying to avoid that and make it a little simpler.
Okay, well, here we seem to have gotten some strange things in here. Okay.
Yeah. Now, what does Galena have to do with PBS?
That's a good question. Let's go take a look.
There was a PBS Nova special once.
Okay, well, it turns out PBS is also the abbreviation for the chemical lead sulfide. We don't want that, so let's go back out here and say we'd like PBS, but not lead,
not
please.
Not references to lead.
And let's try the search again.
Okay.
So
now, I guess that's a
example.
mistake, in fact, one could have made even by thumbing through pages.
This is a artifact of a free text search or full text search.
Yeah.
You get whatever you get.
Okay, and now it's going to pull out the remaining articles that don't talk about that sulfide.
Now we see that there are a good deal fewer articles there, and the Muppets just went by. We're on target this time.
Okay.
And here we are, and let's, for instance, go look at radio and television broadcasting. And it will put us into the article wherever PBS occurs. And it turns out we found an entire outline point on the growth of PBS. So if you're working on a term paper about PBS, there's the
pretty
information.
impressive.
In fact, that's an example. Pull back to the outline level at this point, and you can see exactly what the whole article looks like in outline form at this point. And go in and say, browse around, find something else.
Bob, this is a very impressive example, and this is a very new product, which is actually not quite out.
It's out in 2 weeks.
Okay, on its way. How is this same technology being used in industry?
Of course, this is a replicate technology in which these discs are stamped. The area that you're possibly asking about is how is the write once technology, read many times, applied. And of course there, the document is scanned, converted to a digital bitmap, if you will, and fed into the disk by a focus laser, which physically changes a point or does not change it. On a 12-inch disk, you have 1 gigabyte, which is 1 billion bytes of information that can be stored.
We're going to take a look at a worm demonstration in just a minute. Also, in just a minute, we're going to go to a trade show where the star of the show was a CD-ROM. First, let's take a look at a real-world application of optical storage technology at a library. Wendy Woods reports.
Those of us familiar with endless searching through periodical indexes will appreciate this. Searching is as easy as the touch of a finger on an IBM PC. Here you see a video disc essentially contains the contents of a good wall full of books. It's connected to a micro through a controller and is part of an ongoing experiment by UC Berkeley's library to find the best optical storage reference bank.
Well, it's very useful. What it does, it combines a very large and comprehensive database with the power of a computer, a microcomputer, and allows people to get at the information in the database with non-traditional types of searching techniques.
Here, you just have to type your search subject and all of the listings are there. You can even choose subtopics. This is the creation of Information Access Corporation of Belmont, California. Each video disc holds 530,000 pages from 1,000 magazines indexed since 1982. It's also user-friendly, as evidenced by the logs kept by students. A 4-terminal system with monthly video disc updates now costs about $16,000 a year. But as the price comes down and the efficiency of the systems increase, optical storage is expected to become a lot more common in libraries.
More and more material is available in electronic form now. And in fact, much material is only available in electronic form. So reference rooms are going to have to evolve to handle not only the traditional type materials like books, but materials in this kind of form.
For the Computer Chronicles, I'm Wendy Woods.
This is the Information Industry Association's convention here in Washington, D.C. And the star of the show is this little compact disc. Why? Because it holds a heck of a lot of information. About 600 megabytes, or about 300,000 pages of work. With that kind of storage capacity, applications are not hard to find. There are CD-ROM encyclopedias, 4 years' worth of a newspaper on one compact disc, CD-ROM databases for drugs, and CD-ROMs replacing the old print version of the Realtor's multi-listing book, complete with custom searches and graphics. One of the new players in the CD-ROM field is Digital Equipment Corporation. It's just come out with a CD drive for its Microvax and Rainbow PC. The drive also works with the IBM PC. DEC is offering a variety of scientific and technical databases and some customized applications like this one. A manufacturing company can put all its maintenance manuals on one small compact disc and distribute them around the world. Then, if an assembly line goes down anywhere, the maintenance supervisor can go to the computer, ask for help, find a description and schematic of the faulty part, in this case a robot arm, and complete instructions on how to repair it. Ed Schmidt is in charge of digital CD-ROM marketing, and he says the move to optical storage for computers represents an information age revolution.
Compact disc in particular represents really a major discontinuity in the cost of producing and distributing information, and probably you have to go back to almost the invention of movable type and the printing press to find something that's as step function different than the way it was being done before. I think whenever you have something like that happen, it results in a major new evolution of new applications and technology, and that to me is particularly exciting.
Several problems face the burgeoning CD-ROM business. One is the old bugaboo of standards. DEC has proposed an information retrieval format called Unifile, but there is still dissent within the industry as to which standard should prevail. Another concern with optical storage is a relatively slow access time, but Digital's Ed Schmidt says it's not a problem.
The access time of a compact disc, depending on which manufacturer's product you use, is probably somewhere around 1 second. To a typical computer people, that is a very slow period of time. Magnetic discs have access times of milliseconds. Floppy disks are about 1/4 of a second. However, based on the feedback we've gotten from actual use of this product in applications, in general, the users seeing these applications demonstrated have been impressed with the speed at which the information can be retrieved and shown on the screen.
The big question is, when will CD-ROM systems come down from the factory and the large corporation to the average user? Atari has promised a $700 CD-ROM drive for its new 520 ST, but Ed Schmidt has his doubts.
I'll believe it when I see it. Tramiel has made a considerable number of announcements of products that never appeared and never were shipped, and I think based on what we know about the cost of that product, I think he would have a tough time doing that.
But at whatever price, these new CD-ROMs are incredible. If you wanted to transmit online all the information on this one compact disc, you would have to transmit non-stop at 1200 baud for 46 days.
Stewart, with large databases like that, it just shows a wide range of applications we're going to see with CD.
Okay, I want to ask you more about your encyclopedia in a minute. First, I want to introduce Fred Lloyd, who has joined us. Fred is the head of software development with ISI, Information Storage Incorporated of Colorado Springs, and back with us again, Dr. Robert Kaltoff of Access Corporation. On your encyclopedia, there were no graphics pictures, are there, in the computer CD-ROM version of that? You said you had all that room left over in the disk. What's the problem? Well,
the obvious next step is to go ahead and include pictures. It's not really difficult. You have to just go ahead and digitize or put them in some form that can be displayed again. And then, of course, the next step is to go beyond just simple pictures, but actually some animation and that sort of thing. I guess there's a space problem? Space, not too much of a problem, in the sense that if you try and digitize, say, a black and white picture and get a beautiful resolution, you can take up to about 1 megabyte, but that can be compressed, and there are ways of reducing it somewhat. Okay, we've been talking about CD-ROMs. Now we're going to talk about worm disks, and I want you to explain the difference in the two. Well, about a year ago, I met Fred at the November Comdex and with some of the other people from ISI, and they showed me some of the pre-production versions of their worm drives. That stands for Write Once, Read Mostly. And this is in a comparison with a CD-ROM. CD-ROM is a lot like a book. It's printed. You don't usually write in a book in the same way you don't write on a CD-ROM. And a worm disk is basically blank. It's like a blank piece of paper to begin with, and you write on it, and it accumulates information. But you can only write, but you cannot rewrite. Now, the interesting thing about Fred's system when I first saw it is 100 megabytes per side of the disk, and this makes a fantastic peripheral to a computer system. What basically does this medium cost, anyway?
This media will sell for about $60 a copy when it's in volume production. Our media is enclosed in a really tough plastic cartridge to protect it against the weather and the elements with a stainless steel door.
Now, how do you see the use of this particular drive?
This particular drive can be used not only for backup, for which it's an excellent medium, but also for your online data, things that you use every day but don't change.
So like documentation or programs, things of that sort?
Exactly.
Okay. Now, how have you set this thing up so that you work with, say, an IBM PC?
Well, The initial setup involves nothing more than plugging in the circuit card like you would for any peripheral and running a simple installation program on the disk.
Fred, one of the problems I would think, you've got 100 megabytes aside here. You can store, what, 1,600 files, I think it is, on one of their, something like that. How do you manage all that information on the disk?
The information is managed with our proprietary software, which we make available with the drive, called ISI-DOS. ISI-DOS solves the management problem.
Why don't you show us, if you will, on the
Sure.
system?
And this is compatible with PC-DOS, so it's as far as the file structure is concerned.
Absolutely. It's actually an add-on to PC-DOS that helps PC-DOS understand write-once media.
Okay.
The optical directory, in the case of this disk, currently has 1,600 files on it. It could have as many as 65,000 files on it.
So is this your own personal disk that you use here for your development work?
Yes, it is, actually.
How long have you been using this one disk?
I've been using this disk since last June.
Okay.
And I might point out, it says there 111 megabytes free.
Yes. Yes, that's correct. As we look at the master directory, we see there's a very large number of files. And also, we see that in some cases, the same file will appear more than once. This is something that you won't see on a magnetic drive.
Right, so then you have the revision number that tells you just, these revision numbers just increment as you make new changes to the files themselves.
That's right. That way you always have access to your old file, and you can see how a file is changed on a day-by-day basis.
So this is a perfect archival kind of a device, because you can go back to the very first line of code, for example, of your program, or you can go back to the very first line you wrote for a particular application and recover it.
That's
Okay,
that's
Fred,
exactly
when you
right.
want to write to the optical disk, what do you do?
Writing to the optical disk is very similar to copying with a standard DOS copy command. To write from one drive to another, you would say copy, file name, to another drive. In the case of the IS-DOS system, you simply say IS copy. That tells the system to use the optical drive and followed by the file name. And we're doing that now. And as
You're copying something, what, from the hard disk onto the optical disk?
That's correct. And right now, as we can see, the computer has noticed that there are 13 other versions of this file that I've just copied, so it's automatically told me that I've made an update, a change.
And it's done.
Yes.
It's done it.
And there's no way short of scratching the medium itself, I guess, is to get rid of that particular program.
That's right. It's there for good.
Bob, I want to ask you, how do you see applying this kind of technology, which is pretty impressive, in the workplace and industry?
Well, he is discussing right now computer-related applications, but in my field, we're utilizing this kind of technology to implant documents at 50,000 bytes, which is compressed from 4 million when the document is digitized. We can plant on a 12-inch, 1 gigabyte disk, 20,000 documents, or 3 to 4, possibly 5,000 engineering drawings of an average C size. These then can be communicated to high-resolution terminals across the room, across the country.
Currently, how is that information stored? Is that microfiche? Where you?
Yes, in the engineering drawings, typically they are a 35mm image in an aperture card. These can be automatically delivered to charge coupled scanners as well, and the image lifted and transmitted as well. The same thing can also be done with microfiche or roll film, where the specific images are
So this
digitized.
may lead to the paperless society, then, in a sense.
Oh, don't kid yourself.
Gentlemen, we're out of time. Well, how important is optical storage to the future of computers? We asked our commentator, George Morrow, for his thoughts.
500 or 600 million bytes of storage in a CD-ROM is a lot of space, enough to dazzle even the most jaded systems designer. But bubble memories also promised huge storage capacity, and hundreds of millions of dollars were spent chasing its potential, most of it in vain. Look, any technology that has a lot of potential is going to be attractive. But to really succeed, it's got to fit comfortably in the environment that it intends to serve. And bubbles had a heck of a time ever looking like rotating disk memory. Likewise, the read-only nature of CD-ROMs requires specialized software and unique applications to make it fit right in the normal operating system of a computer. But worse, different specialized software for each different DOS, whether it's IBM, Apple, or whatever. And experience shows that software is the most expensive, difficult, and time-consuming part of any development project. CD-ROMs and bubbles share another common attribute, and that's high cost. These players are going to cost you at least $800, while their audio counterparts are selling for $200 or $300. Thus, the penalty for connecting this technology to a computer rather than a speaker is about $500, a rather formidable barrier to easy entry into the home. That's the way I see it. I'm George Morrow.
In the Random Access file this week, Apple reports that for the first time ever, the Macintosh earned more money for the company than the Apple II. The results are from the first quarter of 1986. Mac sales have boomed in the area of desktop publishing. And Apple is promising to bring out at least 6 new computers in the next 12 months. The first new unveiling is expected to be the Apple IIX. It reportedly will feature a 16-bit chip, making it much faster than the Apple II. It'll also come with an upgraded 6502 for 2E and 2C compatibility. Other features rumored are a detachable keyboard, built-in networking, built-in color graphics, and 4 expansion slots. Zenith has announced the first new CRT technology in years. The new Zenith Flat Tension Mask, or FTM, supposedly eliminates faceplate reflection. The tube is being offered first to OEMs. Some potentially devastating news for the makers of tax preparation software. The IRS has ruled that tax software which provides substantive tax instructions will be considered a tax return preparer, subject to a variety of fines. The potential liability problem could put the tax software companies out of business. Is the microcode on a computer chip software or hardware? That's the fundamental question being decided in a San Jose courtroom where Intel is suing NEC on a copyright infringement claim. If the microcode is software, it can be copyrighted. If it's hardware, it can only be patented. Time for this week's software review, and here's Paul Schindler.
Even if you've never worked in a place with time cards, this scene should be familiar to you. It must be easy to understand. Even the slowest people can use a time card rack. Well, that's just what Paul Heckel had in mind when he created Zoom racks. The biggest problem with database management software is that people can't get a picture in their minds of how the stuff would look if it were on paper. Spreadsheets are easy. Word processors are easy. Database managers are tough. So we have Zoom racks. The first line of each card shows up on a summary. With a single keystroke, you can take a look at a card. Another keystroke takes you back out to the rack. Notice the words look funny. Zoom Racks uses a special smart zoom to make up abbreviations. For example, it says Press Rels Etten. That's clearly Press Release Edition, as we see on the full card. You move around the rack with arrow keys or by typing numbers. We move over to the contact list and assume that HCK is Heckel himself. We're right. Zoom Racks isn't perfect, but it is interesting and it's relatively cheap at $125 from QuickView Systems in Los Altos, California. For the Computer Chronicles, I'm Paul Schindler.
In our legislative update file, California's computer privacy bill is moving to the state Senate. The legislature has a deadline of June 26th for the bill to be included on the November ballot for ratification. And in New York, that state's computer crime bill has moved out of committee. The New York bill creates the new crime of computer trespass, making it illegal to gain unauthorized access to a computer. The University of Maryland has just completed a study on what happens in an office when PCs move in. The results are interesting. Managers move from handwriting first drafts to typing them on computers. Secretaries are used less for first drafts. Managers ask for more rewriting of documents, believing changes are easier to make. Financial analysis moves from mainframes to PCs, and workers stop using the copying machine, printing multiple copies of documents on their printer. A researcher at Virginia Tech is trying to dig up the remains of one of the world's earliest computers, the Mark III. It was apparently dumped in Maryland in the late 1940s. It was the first computer to use drum storage, which eventually led to the disk drive. That's it for this week's Chronicles. We'll see you next time.
The Computer Chronicles is made possible in part by AFIPS, the American Federation of Information Processing Societies. AFIPS, along with these constituent societies, brings you the National Computer Conference, NCC 86, offering a showcase of advanced technology and the industry's foremost professional program. For conference information, call 800-NCC-1986. Additional funding is provided by McGraw-Hill, publishers of Byte. Byte's detailed technical articles on new hardware, software, and languages cover the latest in microcomputer technology worldwide. Byte, the international standard.